Number 21, sodium ion has a charge of positive 1. How many protons are in a sodium ion? So again, the number of proton is always equal to the atomic number. So let's look for the atomic number of a sodium. So sodium has an atomic number of 11. It means we have 11 protons. So the answer here is letter C, 11 protons. So the first part is just a distraction. So make sure to carefully read each problems on the exam. Number 22, which of the following contains 4.21 times 10 to the power of 23 particles or atoms? So in this case, since given yung mass, convert the mass here to the number of particles. So you find out which of the following is equal to this number of particles. So obviously, it would take time, but here we can do an eye-to-eye inspection. So if we look for helium, this is the molar mass of helium, right? 4 grams, that's the molar mass, because if you check the table of elements, the mass is 4.00. Again, the molar mass is the mass of 1 mole of helium. So in this case, this is about 1 mole of helium. And again, for every 1 mole of something, it's always equal to 6.02 times 10 to the power of 23. So obviously, this is not equal to this number. So this is 1 mole is greater than this number. So it's obviously not letter A. Also for letter D, that is carbon, that is 12.1. That's also the molar mass, or that's close to the molar mass of carbon. So that's still also closer to 6.02. So this is also possibly not the answer for this one, because again here I'm looking for this number and this one is smaller than 1 mole. So I'm looking for something na less than 1 mole. Then also for argon, that is 40 grams. So if you look on a table of elements, the molar mass of of argon rather, it's also about 40 grams. So this is also 1 mole, right? 1 mole, and again, it's still closer to 6.02. So possibly here the answer would be neon, because neon, the molar mass is 20.18, and this one is less than the mole or 1 mole of neon. And to check this one, we can do a conversion. We can do the actual solving for this. So let's use the space here. So again, we have 4.21, sorry, 14.1 grams of neon. Again, the first step is to convert the grams into the number of moles. So grams of neon, moles of neon. So for every 1 mole of neon, what is the mass? So here we're looking for the molar mass of neon, and again that is 20.18, 20.18. So right now the grams or the mass is converted to the number of moles, and then from the number of moles, we convert niya siya to the number of particles. And again, for every 1 mole of neon is always equal to 6.02 times 10 to the power of 23. Then if you solve this one, this is actually equal to this number over here. So the answer for number 22 is letter B, 14.1 grams of neon. Number 23, what is the mass of 2.75 moles of H2O? So we have 2.75 moles of H2O. Again, convert this one to the mass. So to convert this one, again, you need to cancel the moles first, and to cancel this one, ibutang sa obos. Then taas would be the mass in grams of H2O. Then when you see this, you are looking for the molar mass of H2O. And again, to get the molar mass, just add the mass of the atoms on the compound. So here we have hydrogen, that is 1.1, 1.01 rather. We have dalawa, that is 2.02, and then for the oxygen, the mass is 16.00 times 1, we have 16.00. So 2.02 plus 16, we have 18.02. That's the molar mass of H2O. That is 18.02. We can cancel the moles. What's left is the grams of H2O. And after this, we can do the operation here. That is 2.75. 2.75 times 18.02. So we have 49.555 or 49.6. That is letter C. Number 24, what happens to the spacing between particles when a liquid is cooled and becomes a solid? So of course, to become a solid, or the particles of solids are closer to each other. So number 24 is letter A. let's skip number 24 because there's a problem on item 24. Let's skip to number 26. A substance that is made up of only one type of atom. This one is the simplest. We are referring to an element. Number 27. Which of the following contains 1 mole of atoms? Again, 1 mole of atoms. So first we need to we can convert each of the mass into the number of moles, or we can just look on the mass because again 1 mole dapat, diba, that's equal to the mass in the table of elements. So for lithium, that is 6.94. So this one is obviously not 1 mole because again 1 mole of lithium must be 6.94. Magnesium, 24.31. So that's the molar mass. Again, the molar mass is the 1 mole of that substance. So it's possibly letter B. But let's check the other choices. Neon, the molar mass of neon, it means 1 mole of neon must be 20.18. So here it's not 20.18, so this one is less than 1 mole. Then for argon, the molar mass of argon is 39.95. We have less than that, so this is also less than 1 mole. So the answer for 27 is letter B, 24.31 grams of magnesium. Next, 28. Which property determines whether an object will float or sink in a liquid? Again, that depends on the density of the given. Next, a metal cube with a density of 0.8 grams per cubic centimeter is placed in a container of water which has a density of 1 grams per cubic centimeter. What will happen to the cube? So in this case, less denser yung object compared to water because again, water has a density of about 1 gram, then yung density ng object is less than 1 gram. So this will just float above the water. Number 30, you have two objects of the same size, but one is made up of lead and the other is made up of aluminum. So the lead has a density of 11 grams per cubic centimeter, then aluminum is 2.7. Which one will float on water? Is it the lead, the aluminum, or both will float, or neither will float? So in this case, both of these objects is denser compared to water. Again, water has a density of 1 grams per cubic centimeter. Both are denser compared to water, so both of these will sink. So neither will float on the object. Number 31. Consider the question, what is the chemical name of the compound Fe3PO42? Suppose the given answer is iron 3 phosphate. What is wrong with the answer? Again, this might not be equal to this number over here because again, this one inside the parenthesis is the charge of the ion. So in this case, we need to check first if this is 3 on this compound. Again, we have Fa3PO42. We have seen this one earlier. So diba, the answer for this must be iron 2 phosphate, number 18, right? So number 18, so this one must be iron 2 phosphate. So let's go back to the choices. So nothing, the answer is correct. Is this correct? This one is not correct. So letter A is not the answer. The prefixes are missing. So are we supposed to use prefix on this compound? Obviously no, because prefix are only used for the covalent compounds. Letter C, the number in the parenthesis should be 2, correct? 3 should be eliminated, or the parenthesis and the number should be eliminated. So the answer for 31 is letter C. The number in the parenthesis should be 2 because again, that's the charge of iron on this compound.